Okay, so we're on question 3 of paper 2 in the November 2019 examinations. Question 3 is an analytical geometry question. This used to be one of my favorite topics at school, a bit of a mix between geometry and algebra. Alright, so the question reads, in the diagram, P, R, S, and T are vertices of a trapezium. P, R, S, T, and PT and RS, these two lines are parallel. We get all this information is on the graph. So we see point S is -3, -7, T is -5, and K, an unknown. But the important thing is this line is parallel to this line. And we'll see the rest as we go along with the questions. So let's start with question 3.1. 3.1. Okay, write down the equation of PR. PR. So that is this line here, PR. And we see the C's coordinate is 0, 5. Just in case you can't see, I'm going to write it down. And R is 3 and 5. So we see both have a Y coordinate of 5. That means our line is just flat. And it is Y equals 5 is our equation. There we go. Alright, let's look at question 3.2. 3.2 is split into a couple of questions. So we'll start with 3.2.1. We're asked to calculate the gradient of RS. And here we go. This is RS, this line here. And we have our coordinates for S is -3, -7. And R we already know is 3, 5. So all we do is we know the gradient of our line RS is the change in the Y values divided by the change in the X values. Alright, so that would be, let's start with R. So we got 5 is the Y value for R, minus -7 is the R value at S, the Y value at S. And we do the same with the X's, 3 minus -3. And that gives us 12 over 6, which is 2. So there's the gradient of RS. 3.2.2, I'm going to do the whole 3.2 in pink here. So 3.2.2, the size of angle theta. Okay, so this angle here, that is theta, and we know that if we have tan of the angle that the line makes with the positive x-axis, that is equal to its gradient, And we can see that, I'll erase this later, but we can see that by imagining we draw a triangle here. So let's imagine we draw this triangle. Then angle theta is equal to opposite over adjacent. And that is just change in y over change in x. So that's why it's equal to the gradient. Alright, so as we see why it makes sense. Okay, so tan theta equals m. So therefore we have tan theta equals 2. Right, because this line is parallel to this line. And we already found out that was 2. And then what do? We say theta equals the arctan of 2. The arctan of 2. And that you can type in your calculator as a shift or a second function. So we'll have theta equals 63.4 degrees. 63.4 degrees. Alright, oh, that degree is a little bit big, but that's fine. That's a degree sign, not a 0. Right, 3.2.3. 3.2.3, what are we asked here? Calculate the coordinates of D. So this is point D here, point D. I'll just write down the coordinates for that. D is 0 and, we don't know the coordinates, sorry. We know it's on the y-axis. So far. Okay, so it's on the it's a y-intercept of line RS. So let's calculate the equation of line RS. The equation. So we know it's going to be y equals mx plus c because it's a straight line. We already had the gradient. We calculated that to be 2, so y equals 2x plus c. And then to find c, we just substitute a point in. I'm going to substitute in point R, any point that lies on the line. So if we substitute in R, R is the point, let me just rewrite that R. R is the point 3, 5. So we'll sub that in, and we get 5 equals... let me write it on here. 5 equals 2 times 3 plus c. This is 6, take it over, we get -1 equals c. Alright, so we know that's the y-intercept, so that'll be part of D. So D, the coordinates for D will be 0 because it's on the y-axis, and -1. It's the y-intercept of our line. So 0, -1. There we go. That's answer 3.2.3. Okay, 3.3. Let's change up the color a little bit for this one. 3.3. It is given that TS, the length, is 2 square root 5. Calculate the value of K. Okay, let me just write down some of the information and then we'll go back to the graph. So TS is 2 square root 5. That's the distance. And we need to find the value of K. Now, where is K? So this is the point T. So let me just write down T's coordinates. T is -5 and K. Okay, so -5 the x value, K is the y value of T. So this distance TS, they told us that distance is 2 root 5. Okay, so we're going to use our distance formula. Now the distance formula just comes from the Pythagorean theorem. So I'm going to say TS equals, and the formula, I'm just going to write on the formula for all of you to see what the formula is. So it's the difference between the x values squared plus the difference between the y values squared. Alright, now TS we know is 2 square root 5. 2 square root 5 equals, and then we can plug in the values here. So the difference between the x values, let's go up just a little bit. So we see the difference between, I'm going to write T first. So the difference between x values is -5 for T minus, and then -3 for S squared, plus difference between the y values squared. So that's K for the T and -7 for the S value squared. Alright, now I'm just going to square both sides to get rid of the square root. So square that. Now we get, okay, if we square this, we get 2 squared is 4, squared 5 squared is 5, 4 times 5 is 20, equals, okay, and this -5 plus 3 is -2, plus, here we've got k plus 7 squared is k squared plus 14k plus 49. Alright, and now we just have a quadratic trinomial that we need to solve. So I'm just going to put a 0 here, and this is k squared plus 14k, and then we've got plus 49, plus 4 which is 53, minus the 20 which is 33. And we can factorize that, so 0 equals k minus 11, plus 11, k plus 11, and k plus 3. There we go, so either k equals -11 or k equals -3. So now we need to decide which one of these two is our answer. Alright, so what we can see on the diagram here is that k or t is above s. Right, so we know the y value has to be bigger than -7. So it has to be the -3. Alright, so it has to be the -3, so that is our answer. This one is not our answer. Alright, that was question 3.3. So we just used the distance formula and plugged in the values to solve for the missing term. Okay, let's go to question 3.4. 3.4. Whoa, sorry, something went wrong with my pen there. 3.4. Parallelogram TDNS with n in the fourth quadrant is drawn. Calculate the coordinates of n. Okay, so we're saying TD, so TD, and then NS. Okay, this is TS, and n they say is in this quadrant. So something like that. So that will be our point n. And now we need to find these coordinates. Okay, so the thing about a parallelogram is we know that opposite sides are equal and parallel. So then these two would also be equal and parallel. So the movement from T to S is exactly the same as the movement from D to N. Or you could say the movement from T to D is exactly the same as the movement from S to N. Oh, sorry. So let's do that. I'm going to say the movement from T to S is, let's see what that movement was. So T was -5 and -3. S was, or S is -3, -7. -3, -7. So for the X values, how did we move? We went from -5 to -3. So for the X values, we said +2. For the Y value, from -3 to -7, we said -4. So now we just want to apply this to the point D. So because that'll be from D to N will be exactly the same as what we did from T to S. So point D we had 0, -1. So we're going to apply X plus 2. So from D to N. So X plus 2, which means 0 plus 2 is 2. And then Y minus 4. So -1 minus 4 is -5. So there we go. That's the coordinates of N. That's the coordinates of N. And then finally we get to question 3.5. Question 3.5. Let's do that one in black. Question 3.5. 3.5. Alright, triangle PRD is reflected about the y-axis to form P prime, R prime, D prime. Calculate the size of angle RDR. RD prime R. Ooh, okay, let's see what happens here. So reflected PRD. So PRD, this triangle here, is reflected about the y-axis. Okay, so if we reflect every point about the y-axis, let me draw that in red. So D would stay exactly where it is. This point would go here, and that point would go there. Right. Okay, so there we have our new triangle, and now we are asked to find the size of angle RDR prime. So RDR prime. So that's this angle here. This angle. Okay, that angle there. Now, what we can do, I think what I would do is, well, there's a couple of methods. I would say we already know. Let me just draw this triangle. Draw this triangle again for us. So our triangle over here. Yeah, let's do it over here. Okay, this triangle. We need to find this distance. So we already know this gradient of this line is 2. And let's draw the y-axis in here somewhere like that. Okay, so we already know this angle here, this gradient is 2. We can find this gradient as well. Okay, so this was point R, which is 3, 5. This is point D, which is 0, -1. And this is point R prime, which is -3, 5. Okay, so let's find the gradient of R prime D as well. So the gradient of R prime D, that's a change in y over change in x. So 5 minus -1 over -3 minus 0. That gives us 5 plus 1, 6 over -3, which is -2. Okay, so this gradient is -2. -2, alright? Though some of you might have been able to guess that even before doing the calculation because of the reflection. Okay, so if we have both of those being 2 and -2, now we could find the angle, right? So if we said let's draw a horizontal line here, a horizontal line there, we know that the angle theta, this angle is, if we tan of theta would equal 2, and if we want to find this big one, right, or even that one, we know that's going to be pretty much the same as this one, right? Just a negative. But these two will be the same. So we can say 180 minus theta minus theta. But let's quickly do the calculation. So tan of theta equals 2. If we type that in the calculator, we already saw that's 63.4 degrees. Alright, and if we do tan theta equals negative 2, well, we actually don't do the negative 2. We usually just do 2 to get our reference angle. So then our reference angle is 63.4. But now we check. Okay, so tan in this quadrant is negative in the second quadrant. And the second quadrant is 180 the minus. That's that quadrant, right? So we'll do 180 180 minus 63.4. 63.4. Actually, we don't need to do that. We don't need to do that. That's fine. We can just, this reference angle, we can just say, okay, so that gives us, that'll give us negative tan, because it's in this quadrant where tan is negative. So that'll just be negative 63.4. Negative 63.4. And that's fine. That's fine. That's all we need. Which the negative just means going this way, or going clockwise, really. That's just what negative means. So if both of these are 63.4, oh, I did the wrong thing there. If both of these are 63.4 and 63.4, then we can say 180 minus 63.4 minus 63.4, because a straight line must be 180, and that will give us, what is this, 126.8. So 180 minus 126.8, and that gives us 53.2, I believe, 53.2 degrees. Okay, yes, that works out. Alright, so that is our answer. So the tan theta equals the gradient. That's a useful formula to know for calculating angles. Alright, so that was question 3. Please join me again for question 4.